All right, thank you all for joining. I will be showing you a couple of things today about networking in Linux, and the focus will be especially on the virtual networking and things like macvlan and ipvlan. And I don't know if I have time to get into the Docker side of networking and see a couple of things there. But anyway, um, here is my agenda for tonight. I hope I can cover this in 60 minutes, and maybe at the end we will have a short Q&A for 20-30 minutes. So let's get started right away. First, if you are somehow familiar with Linux for a while, maybe you know a couple of things about how to configure network settings, especially the interfaces and the IP settings of the interfaces. And you know, of course, that each distribution has its own way of doing things. Um, and Let me see here. For example, with Debian, sorry, most of the stuff you will find it under etc network. Maybe you will look into the interfaces with Red Hat based distributions. Sorry about this. You will find the configuration files under sysconfig or sysconf. I don't remember exactly. Actually, I have here a CentOS machine. Sysconfig network scripts, I think, is right. So here you have all these configuration files. I'm not going to talk about this today. It's just like a quick reminder. So the point that I'm making here is that each distribution has a couple of configuration scripts that you can configuration files that you can use to configure networking, and these are actually also used for permanent configurations. But apart from this, the most familiar command that you might know is the ifconfig command. So traditionally, ifconfig has been used for network configuration, but in the latest years, you might have seen that it's becoming legacy, and IP Route 2 is replacing it. IP Route 2 is not a new tool. It's also, I don't know, I know about IP Route 2 for 12, 15 years. I don't remember exactly, but it has some history. But um, comparing to ifconfig, IP route has been evolved more. So you might notice that in newer distributions you don't even find the ifconfig package, the ifconfig tool. The The ifconfig tool is part of a package. I think it's called net tools. I think I'm not sure, but we can verify that. It's not very important anyway. And IP route, it's from IP route 2. It's not so important anyway. The Another thing that I want to tell you before I show you a couple of examples is that IP route uses netlink to communicate with the kernel. So IP route is a user space tool that is doing kernel configuration through netlink. All right. So as I said, I'm not going to talk. My focus will be on IP route. So if config, I'm not going to talk anymore about it. And I recommend you to try and become comfortable with IP route, because this is the not the future, the the tool that we are using mostly today for network configuration. Of course, uh, again, if you're talking about specifics of a distribution, there are configuration files and scripts that most certainly are using IP route for uh, in the scripts and for the actual configuration. And one thing that I noticed that I said here IP route, but it's actually the tool. It's not called IP route. What am I doing here? But IP. It's not so important, but you will see in the examples. So as you will see, IP is a very friendly tool. Maybe not at first sight, but the thing that I like most about IP is the contextual help, and the fact that you can display help for each section that um, that you want to configure. So if you go with the IP help, like the root of the command, you can see here that IP can be used to affect a couple of object types, and the objects that we are going to use mostly are link and address, and route, of course. These three are the most important, and after these three, you will maybe use this one, neighbor. This is for manipulating the ARP, the ARP table, and maybe this one, network namespace, and who knows, maybe VRF. Um, and let's see our first useful command. Sorry, IP link. With this, we can display our links, and we have a couple of parameters that we can use to display more verbose information or more brief information. For example, if I go with IPD from details, link show, you can see it gives me more information. Let's focus on a single link. Let's take this one, EMP0S9. So IP link show S9. You can display the information for only one link if you want, like this. So if we repeat this command with the detail flag, it gives us a bit more information. So let's try to explain a couple of things, um, a couple of the things that we are seeing here. So the network link is this one. Is the fourth. I think this is. I don't know if this refers to the fourth interface detected by the kernel. Maybe not. But the important things. This interface supports broadcast and multicast addressing, of course, also unicast, but is not shown. It is up, and it is up from like from the logical perspective, and also from the physical layer. This one lower up tells us that the physical interface is up. The maximum transmission unit is the default 1500, and Q discipline is this one. I don't know too many things about the Q disciplines. Again, the state is up, Q length, and here also important is the MAC address of the interface and the broadcast MAC address, which of course is all FFFFFF. And for the detailed description, there are a couple of things after the MAC address. As you can see here, the promiscuity, the interface is not in promiscuous mode, and some other things. So what have we learned until now? We learned how to display the network interfaces and how to control the verbosity. Also, you have a brief flag. So if you are using this flag, you can see that now it only gives me the status of the interface and the MAC address. And there's another flag, also important, if you want to display like the counters of the interface, like how many packets were processed by the interface. You can do it like this with S flag from statistics, and here you have it. The transmitted, and there is you can read it like this: the received and the transmitted. So packets, errors, how many dropped, multicast collisions. So quite a lot of information that you can display only with the link object. If we are displaying the help for the link object, you can see that apart from the show action which we experienced, we have other actions also. The most important being the addition and the addition, the deletion, and set. So we can add other links, especially the virtual links that I'm going to talk about. We can delete them, and we can set a couple of parameters for these links. So also the main parameters, or the main important parameters that we want to manipulate, are the status up or down of the interface, the promiscuity of the interface, the maximum transmission unit, the network namespace in which the link should reside. If we want to create an alias, is not so important. And also the master device. you will see maybe for the bridge interfaces. Yes, when you have bridge interfaces, we have for the bridge interfaces we have slave interfaces. So if I have, for example, an interface called bridge 0, um, I will associate interfaces to that bridge, and I need to set the master for those interfaces to bridge 0. Doesn't matter so much in this point of the discussion. So I will show you very quickly how to add and delete a link. Let's see. I think I have a link that doesn't belong here. This one, IP0. It's from some old test that I did, and I want to get rid of it. All right, with the delete IP0, and now, as you can see, it's gone. So I will create now a new link. Let's look at the syntax for a moment. It says add optional link device. You are using this if the link you are adding is slave of another link. You will see an example for this with the macvlan and ipvlan, and also with the Vlan interface, which is actually a sub interface. So if you are creating a sub interface of, I don't know, ETH0, you need to specify here the master link, which will be ETH0, and after that the sub interface. But right now we are not creating such interface. We are creating just I want to create a dummy interface. So my dummy 0, and we need to specify the type. So this is the name, my dummy 0, and then we need to specify the type, which is dummy. And we can specify some parameters for this type if we want. Is here in the syntax. We can specify some arguments, but we don't want to do that. So now let's list the links. Sure enough, I have here my dummy 0 interface. Let's see the set action of the IP link. Let's check the interface. So first we have the device, and then the parameter that we want to set. So IP link dev my dummy. Actually, you can put the arguments in different order also, in a different order also. But I'm showing you exactly how the syntax is presented in help. So IP link set, actually I want to specify the action, and what do I want? I want to change the status to up. So here in the previous list is down, and right now is up. Actually, it's unknown, the status. My dummy. This might be because it doesn't have an IP yet. Anyway, you can see the change right here. You have here in this angle brackets, you don't have this status, this up and lower up. So I've showed you how to add the interface, how to delete the link, how to delete the link, and how to set a parameter for the link. Um, of course, we can change the MTU. We can put it in a different namespace, and I will actually show you about this. But right now, I will show you the other very important module of the IP command, which is address. If you just type IP address or just IPA, it will give you all the links together with the IP information. See here for this one, EMP0S3. It also shows you the layer 2 addressing, but that's not so important right now. What is important is the IP address information that it gives you. Also with this module, the brief flag works, and things are very similar for each module of IP. The same, we can restrict the output only to one interface. For example, NENP0S3. What? Uh, um, we need to type the full command with the show action. And here it is. EMP0S3 is up and has this IP address, also the IPv6 version. Now, so let's see the help of this module. We can see the important actions: addition, change, and replacement, and also deletion of the IP address. So right now, let's add an IP address for our previously created MyDummy0 interface. So I will give this IP address MyDummy0. All right. If you want, you can restrict the output also with type dummy. I'm displaying now only the dummy interfaces, and you can see here the IP address that I've set. You can add multiple addresses if you want. So as you can see right now, I have two addresses. Of course, you can delete addresses. I will delete the first assigned address. Sorry, type. So this is how you can manipulate addressing using the IP command. And the last module that I said is important is the route. So with this one, you can add routes. I'm not going to show you right now an example. So let me see what else I want to talk right now. Um, let's talk about the link types that we can have, and especially with in this virtual networking stuff. Um, so we can create. I've shown you how to create dummy links. So for sure, this is one type of interface, but the important interface types that we might want to create or manage are bridge, macvlan, ipvlan, and I also want to tell you a couple of things about virtual Ethernet. All right, so let's talk about bridge. If you know some networking, you know what the bridge does. The idea is that you can configure this functionality um, in Linux. This functionality is supported by the Linux kernel. And when you are creating a bridge, first thing is you create a master interface. Let's call this bridge BR0. And this master interface will have an IP assignment. Let's say we have 192.168.1.1. And under this master interface, you will have slave interfaces like EMP0, S1, S3, doesn't matter, ETH0. So this is what constitutes a bridge. If you inject traffic on any of those interfaces, the Linux box will behave like a bridge. It may uh, um, associate the MAC address on the interface exactly like a bridge. It has a CAM table. Uh, it uses spanning tree protocol. It uses .1q tags, things like this. So this is the bridge interface. Also, it's not enough to use IP in order to manage bridge. This is why I'm not going to insist too much on this type of interface. You need the bridge utils package with the most used tools are this one: bridge control and bridge. And with these ones, you can manage the VLAN database. You can manage the spanning tree protocol um, and things that you normally configure on a bridge. you cannot do all of these things only with IP. You can create the bridge, you can associate interfaces to it, but there are a couple of things that you will not be able to do just by using IP. So let's see if we have a bridge interface on my system here. ipvlan show type bridge. And as you can see, because I have Docker installed, I have this interface, Docker 0, which is a bridge interface. It has an IP address, I think. Yes, it has. And also I will show you about those tools that I've talked about, bridge, and the other one is bridge control. You can see with the bridge control we can add a bridge, delete, add interfaces to the bridge, set a couple of parameters, enable spanning tree, and with this one also. Anyway, as I said, I'm not going to insist on this. Maybe in a future lesson, who knows? So let's see about the other interfaces or interface types. macvlan. macvlan is a, I don't know, like a simplified version of the bridge with regards to features. So in macvlan we have a master interface. Let's say this is ETH0, and under this interface we have different slave interfaces. Let's say we have Mac Net 1, Mac Net 2, and each interface has its own MAC address. And whenever you are another condition for macvlan to happen is that this master interface should be in promiscuous mode. So whenever this one receives a frame, it will accept it uh, whatever address that frame has, and it will forward it to this. Actually, it will forward it to, if that address is one of those slave interfaces, it will forward the frame to the corresponding interface. And also the slave interfaces can communicate with each other. Actually, this depends on the mode. I will show you. There are 4 modes actually in macvlan, and but usually it's like a switch which doesn't have to dynamically learn MAC addresses. It has like a static CAM table. You can say that. and the modes of the macvlan are private. In private mode, the sub-interfaces cannot communicate with each other. They can only communicate with the exterior through the master interface. Then we have another mode which is called VEPA. Um, in these modes, the sub-interfaces can communicate with each other, but only through switch that is doing hairpinning. So uh, we need to have here a switch that is doing hairpinning. The one mode that we are going to use is the bridge mode. Is the only one supported by Docker. And there is another one, I think, pass through. I'm just listing them here. It's not that we are going to use them anyway. So this is the macvlan. I will also talk really quick about the ipvlan. ipvlan is somehow similar with macvlan. We also have a master interface. And under this master interface, let's say we have IP interface 1 and IP interface 2. The main difference here is that those sub-interfaces do not have a MAC of their own. They are using the MAC of the master interface. And we have here also we have modes. Only two this time. Layer 2 mode and layer 3 mode. In layer 2 mode, it behaves exactly like, or not exactly, but very similar with the macvlan, except that we are not using distinct MAC addresses. All the communication from these sub-interfaces will come with the same MAC address as the master interface. And in layer 3, the main difference is that broadcasts are not forwarded. So in layer 3 is like ETH0 is or the yes, it's like a router that knows the routes to the directly connected interfaces. Sorry. So whatever IP we are configuring on this interface, this one will know the routes. So if we are configuring here on IP interface 1, we are configuring an address like 1, 2, 3, 4. If we have the default gateway here, the ETH0, for sure our traffic will be able to reach this address. I'm running out of time, so I will get to examples quickly in a moment. So this is like the theoretical part of ipvlan and macvlan. I also shown you in the previous slide about virtual Ethernet, but I don't know if we have time for that. So let me get back here and let's try and create some macvlan interfaces. So I will delete all the dummy interfaces. Alright, so now I'm creating a link of macvlan type. And I want to use this as the master device. I think I want to use this. Let's see the address of this one. No, I don't want to use this. I want to use this one. Alright, so IP link add, and we are specifying the master link, emp0s8, then the name of my interface, which is macnet1, of type macvlan. And I told you about modes, if you remember, the private, bridge, VEPA, and we can specify also mode here. But if we not, what device or resource busy one, I don't know. Why is that? Let's see if I'm using another S9. I cannot use this one right now. I'm not sure why. Anyway, I will be using this one, EMP0S9. So a very important tidbit, let's say, not a tidbit, but it's an important detail. If you want to find out the mode of the macvlan interface, which as you can see is not displayed by default, you need to go with the detail flag. And as you can see, it's in VEPA mode. And I do not want VEPA mode. So I will delete this one. And I will create another one with the bridge mode. I link type macvlan mode bridge. So right now, if I'm going with the detail link show macnet1, as you can see, we have macvlan in mode bridge. I will create another one. Magnet2 type macvlan mode bridge. Let's display this. Link show type macvlan. So I'm displaying only the macvlan links, the previous created, the ones I created. So this one, magnet 1 and magnet 2, and also you can see here the master interface. This is the notation that that is used. So what I want to do right now is to move these two interfaces in different namespaces. I know we haven't talked about namespaces, but hopefully you will get it as I'm showing it to you. And I will be moving those in two different namespaces and then try to ping from one namespace to another and also to the default namespace. So let's do that right now. IP link set magnet1. Actually, I have to create the namespaces first. Let's see what namespaces do I have. I have two namespaces. I will delete those. Delete. And I will create them again. Actually, I have deleted them because I don't know what I had in those namespaces. Anyway, I'm creating the namespaces again. And now I'm going to move the macvlan interfaces. Link what? Magnet IP link set dev magnet2 network namespace ns2. So I moved the magnet one in namespace one and the other one in namespace two. And if I want to manipulate things in a specific namespace, I can use ipnet namespace exec. Where is it? Blah 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 blah. Exec. This one. So ipnet namespace exec ns1. Let's, for example, display the links. What? ns1. Okay, so now I will be modifying the status to up and assign an IP address, IP namespace exec ns1 IP address, put it to up, link set dev magnet1 up. What? Magnet IP link set. What? Sorry. Magnet1 is in namespace 1. Magnet set dev magnet1 up. Net namespace exec yes. And I will bring up the secondary interface also from the other namespace. Okay, let's display this. IP namespace exec ns1 IP link show. Alright, so magnet1 is up. Let's assign an IP address to it. IP net namespace exec in ns1 IP address add 192.168.100.10/24 magnet1. Let's display it again, IP address. Okay, so we have this one. Let's see the other namespace. Net namespace exec ns2 IP. So is up here also. Let's put an IP address to it. Magnet, sorry. So it is. The IP address is assigned. So right now let's try to ping from one namespace to another to the other. So -1 ping 192.20 is the address from the namespace ns2. So it's working. What about if I want to communicate with the default namespace? If I want to communicate with the default namespace, I need to create a macvlan interface in the default namespace. I can communicate with an interface that is connected to the master interface, in my case EMP0S9. So I have created my macvlan interfaces attached to this one, EMP0S9. So as I said, I can communicate with interfaces that are attached to this interface, like physical interfaces that are attached to this one. But with the host of this interface, I can only communicate if I am creating a macvlan interface that is attached to this local host. This is what you will have to do if you are creating Docker networks of macvlan type. So let's do this right now. Ip-link add as a slave of the link emp0s9, name macnet0 of type macvlan of mode breach, if you remember. So here it is. Let's bring it up and assign an IP address. Let's say 100.1. So if I'm displaying all the macvlan interfaces, right now it's displaying the interfaces from the default namespace. And here it is. So now let's try and ping something from one of those namespaces. So it's working like a charm. So this is it on very fast forward, I think, with macvlan. I'm going to show you also the ipvlan. I hope I have time and I'm not rushing it. Let me see if I have any questions here. Okay. So let's do also the ipvlan part. So I'm going to create the links, the same as with macvlan. I'm going to create two ipvlan links, and I'm going to use from the start layer 3 mode, ip-link link emp0. Let's see if I can do it with the emp0s8. I don't know what's keeping it busy. emp0s8 name ipv1 type ipvlan mode L3. Okay, it's working. So let's create the other one. we have this. I will create also 2 additional namespaces. So we have these ones, and now I will be moving the interfaces to the namespaces. Dev the other one in the other namespace, and I will bring them up. Let's list the interfaces here. Okay, and bring it up. Ipvlan set if1 up, and let's assign also an IP address. .200.10. All right. So this one is done. Let's configure the other one in the IPNS2 namespace. Let's list the interfaces in the IPNS2 namespace. Right. So this is it. Let's see also on this other namespace. And now let's try to ping from one another. IPNet namespace IPNS1 ping. What? Again. So it's pinging. As I told you, it's working like a router. And if I'm adding, let's display the routes in one of those namespaces first. I can also use IP for routes with the route module. So right now I have the route only for the direct connected link. What I want to show you now is that I will add a secondary IP address on one of those interfaces. Let me show you. IP IPNS1 201.10 if1. What? I keep Mistype this. So I have the secondary IP address here. If I'm trying to ping it from the IPNS2 namespace, it won't work for the moment. It's unreachable because I don't have a route. But if I'm adding a route here, actually the default route, I'm just adding it through the device like this. Let's display the routes again. See, right now I have the default route. It should work. Let's see. Yes, it should work, and it is working. And in the last 5 minutes, I will draw you a couple of things about this last demonstration that I did with ipvlan. One last thing that I want to tell you about this is same as with macvlan. If I want to communicate with the local host, I need to add ipvlan link in the default namespace. And also, if I want uh, to route from the default namespace, I need to, if I want to reach the networks in those namespaces that are configured on ipvlan interfaces, I need to add routes on my default namespace, same as I did with routes in the IPNS2 namespace. So let's get back to the drawing board here, and let me see if I can make things a bit clear for you. So what I did here on ENP0S8, this was the master interface, and I told you it's working like a router. And I had here IP if1 and IP if2, and as long as my default route points directly to this interface in this namespace, I am able to reach any connected ipvlan interface. And if I want to communicate in the default namespace where the master interface is assigned, I'm not going to assign an IP address on this master interface, but I'm going to create another IP interface, let's say 0, and all the routes we had there, let's say 192, 168, 200, and 192, 168, 201 slash 24. All of these networks, I will be routing them through IPF0, which is the ipvlan interface from the default namespace. So I know it's maybe a fast paced presentation, but I'm hoping you managed to get something from it. So now let's see if you have any questions or things that you want me to to show you specifically or explain more. So I will be waiting for your questions here in the chat. If you are still with me, I don't know, maybe you fell asleep. Anyone? All right, I don't want to keep you anymore with this. So again, I hope this has been somehow helpful to someone, and maybe I will see you in a future presentation. Have a nice evening. Bye bye.